This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to today's discussion. We're diving into the fascinating world of interactive physics simulations, specifically focusing on a study guide for an AC circuit simulation. It's a powerful tool for learning, isn't it?
Absolutely. Interactive simulations bridge the gap between theory and practical understanding, especially in complex fields like AC circuits.
Exactly. This study guide seems to cover a lot of ground. What immediately struck you as particularly useful about its approach?
The emphasis on visualization. Seeing the voltage and current change over time, coupled with a visual representation of electron motion, makes abstract concepts much more tangible.
And the interactive elements, sliders, combo boxes, play/pause, how crucial are those for effective learning?
They're essential. Sliders allow students to manipulate variables and see the immediate impact on the circuit's behavior. The combo box offers different perspectives, allowing for a deeper exploration of various circuit configurations.
So a student could, for example, adjust the resistance using a slider and instantly see how that affects the current?
Precisely, but they can experiment with different resistor, capacitor, and diode combinations, observing the resulting voltage and current waveforms. This hands-on approach fosters a much deeper understanding than passive observation.
The study guide mentions visualizing electron motion with a moving dot. How effective is that visual cue in conveying the concept of current flow?
It's a brilliant simplification. While the actual electron movement is far more complex, the dot provides a clear, intuitive representation of the average electron motion, making the concept of alternating current much easier to grasp.
It's a great way to make an abstract concept more concrete, especially for visual learners. What about the different simulation modes offered by the combo box?
The different modes of focusing on resistors, capacitors, diodes, or combinations thereof allow students to isolate the effects of each component and compare their behavior within the AC circuit. This targeted approach enhances understanding.
So a student could focus solely on the capacitor's behavior in an RC circuit, isolating that variable for better comprehension?
Exactly. This targeted approach is far more effective than trying to understand all components simultaneously. It allows for a gradual buildup of knowledge.
Let's talk about the overall pedagogical benefits of using this type of simulation in education. What are the key advantages?
Interactive simulations offer a dynamic learning experience that traditional methods often lack. They allow for self-paced learning, experimentation, and immediate feedback, fostering a deeper and more lasting understanding.
It's a powerful tool for inquiry-based learning, allowing students to formulate hypotheses and test them directly within the simulation environment.
Absolutely. It encourages active learning and problem-solving skills, moving beyond passive absorption of information.
The study guide includes a quiz and essay questions. How valuable are these assessment tools in reinforcing learning?
They're crucial. The quiz tests comprehension of key concepts, while the essay questions encourage deeper reflection and application of knowledge. This combination provides a comprehensive assessment of understanding.
The essay questions in particular seem designed to promote critical thinking and analysis of the simulation's features.
The inclusion of other related resources is a significant strength. It provides students with a broader context and encourages further exploration of related concepts.
It's like a gateway to a whole universe of interactive learning materials, all within the same platform. This interconnectedness is very valuable.
Precisely. It fosters a sense of continuity and allows students to build upon their knowledge progressively.
The study guide also mentions the Creative Commons license. What's the significance of this open access approach?
It ensures widespread accessibility and encourages collaboration and sharing of educational resources. This open approach benefits educators and students globally.
It's a testament to the power of open educational resources in promoting knowledge dissemination and collaborative learning.
This simulation is versatile. It's suitable for classroom instruction, self-study, pre-lab or post-lab activities, and even online learning environments.
It caters to a wide range of learning styles and educational settings, making it a truly adaptable resource.
The interactive nature makes it engaging for students of various levels, from secondary school to introductory college courses.
Are there any limitations to the simulation or areas where it could be improved?
While the simulation is comprehensive, further development could include more advanced circuit configurations or the incorporation of real-world applications.
Perhaps adding more complex circuits or scenarios to challenge more advanced students?
Exactly. And perhaps incorporating more detailed explanations or tutorials to guide students through the learning process.
Overall, the study guide provides a well-structured and comprehensive approach to learning about AC circuits using interactive simulations. What's your final takeaway?
It's a powerful example of how technology can enhance learning, making complex concepts accessible and engaging for students. The interactive elements, visualizations, and supplementary resources combine to create a truly effective learning tool.
I completely agree. The blend of theory, practice, and interactive exploration makes this a valuable resource for educators and students alike. The study guide also highlights the contributions of Fuqun Wang and Fremont Teng. Their work in developing this simulation is commendable.
Indeed. Their dedication to creating accessible and effective educational resources is truly valuable.
The FAQ section within the study guide is also a useful addition, addressing common questions and clarifying potential misunderstandings.
It's a great way to proactively address student queries and provide clear guidance.
The other resources section is also a great way to expand the learning experience beyond the scope of the AC circuit simulation itself.
It provides a pathway for students to explore related concepts and deepen their understanding of electricity and magnetism.
The instructions section is also very helpful, providing clear guidance on how to use the interactive elements of the simulation.
It's essential to have clear instructions to ensure that students can effectively utilize the simulation's features.
The glossary of key terms is also a valuable addition, providing clear definitions of key concepts related to AC circuits.
It's a great way to ensure that students have a solid understanding of the terminology used in the simulation.
The sample learning goals section, while not explicitly detailed in the provided text, is an important component of any educational resource.
It provides a clear framework for the learning objectives and helps to guide the learning process.
The For Teachers section is also a valuable addition, providing additional resources and guidance for educators. That was a great discussion. Thank you for your insights.